you will see that you have two classes over here, Scala main and Scala main $, which is basically a companion object, which contains the static methods for the Scala main class. Okay, so but the thing is, this is the same bytecode. If I do Java P Scala main, Java P, I mean Java dissembler is able to see the bytecode and it's able to see the same method. And if I do like Java P Java main, pretty much you will see that it has the same method Java main as in Scala main. So from the JVM perspective, both are the same. So that's where Java and Scala are actually mingling with each other, and that's why they are interchangeable. Because from the JVM perspective, where everything runs, I mean, bytecode is a source of all truth when it comes to JVM. It's all the same, and that's why if you have a large code base in Java, you can use Scala. That's why you are able to use Scala code with it, and vice versa. Yes.
In Java, we have it's an object type, so everything we write it's under the umbrella of object. So which we can see over there, like on Java main is having a default constructor, and you get default methods
okay.
that are there in
right. That's why I didn't show you companion object Scala main. Those methods are captured in the companion object. Okay, so if you notice the companion object, I can put the P flag, put the -P flag, which will show you private methods too. Over here, it has a private constructor because I told you like this is a companion object. At the end of the day, they will be equivalent when they run on the JVM. Okay, the reason, as I explained, I'll talk more about it because it's a little bit advanced concept. Is that, as I said, Scala being more pure than Java, it does not, when you code, it does not allow you static methods. But in order to run it on the JVM, it creates a companion object and put all the static methods in there for you. Okay, so from the JVM perspective, it's the same bytecode. Yes, it creates an extra class and puts the, but it's following best practices. You will see when you code more that singleton class is used very often. And in Scala, it's as easy as creating an object type. Writing just, instead of a class, put an object, you created yourself a singleton class. Okay? So that's the idea, basically. A lot of design patterns are actually inherently built into the Scala language itself. You will find that later on. So that's the end of the demo. If you have any questions, let me know, and then we'll move on and do some more demos and talk a little bit more about Scala internals. Okay. So let me just go to my presentation back, and so we talked about that. Now we will come to the seminal question. What's wrong with Java? If you are a Java developer and you will say that, why do I have to learn Scala? I mean, you don't have to. I mean, basically, whatever you can do in Scala, eventually you can do it in Java. But Scala makes things a lot more easier, and it has concepts which are much more neater, and a lot of functional programming concepts which are available in Scala only through external libraries. They are not inherently built in the language itself. So the first thing I'll say is that the Scala, when Java was first designed, right? Yes, it has a lot of multi-threading concepts in it, but if the threading model itself was incorrect. It was fixed in Java 5, but it still continued to be a very verbose language. For example, if I want to write very simple line of code like thing, I have to type thing equal to new thing. In Scala, you can actually omit this typing, and Scala compiler will infer it for you. And I'll show you some examples for that too, right? And there is too much boilerplate code you have to write, like when you are writing classes for getters and setters, overriding the main methods and all that. That can all be avoided by using Scala code. And eventually it will boil down to the same bytecode, so it doesn't matter, right? If you're running on the JVM. So what are, I mean, it doesn't do justice for me if I don't point out what are the good things about Java. I mean, I've been a Java developer for most of my life. It's only been like last 4 or 5 years I've been doing Scala. But I just want to say Java is very popular. I mean, look at it. I mean, go on the internet and you can find library for almost any type. And Java has overall proven its worth over and over. I mean, it's if you look on DICE or somewhere, most of the programming jobs are in Java because it has withstood the test of time. When I say Java, it's a JVM I'm talking about. I'm not talking about the other things, maybe, right? It's mostly object oriented, and I will talk more about in next slides why I say it mostly and not entirely. It requires strong typing, which means you have to define your types, right? And it's a good thing because then you can find your problems at compile time itself and don't delegate your problems to the runtime. I mean, that's why generics were created, right? 1.5 generics were created for one and one reason only. And that is not to write generic code because that was inherently built into the Java itself because of the implicit object hierarchy, but to have a type safe code, to find most of the problems at compile time itself rather than at runtime, right? So it's a very strongly typed language, which is a good thing, but there are some crooks in it which Scala try to fix for you. There are a lot of fine libraries which are written, in Java itself. Like most of the big data solutions, like Hadoop, every API is almost underneath the covers it is written in Java, right? It's only that Spark has adopted the functional way because they wanted to scale much better than Java itself. And the best thing, as I mentioned again and again, it's the JVM, which is platform independence, highly optimized. And let's say today you write some bytecode, right? And it is running on one machine which has 4 cores, right? And it may not have that much features in it, right? If you take the same bytecode and run it, which is highly optimized, it has much better features. It runs on the same, but with a better optimized way. Why? Because the JVM is abstracting that model from you. The JVM inherently, if you upgrade a JVM, you get a better garbage collection. Maybe you might get better other features which are newly available in the, you can take advantage of the underlying hardware features, right? So the point is, it's a JVM, which is a real powerhouse out of all the ecosystem of the Java. And that's what other languages are trying to use. I mean, Scala does the same thing. It replaces everything, but uses the same JVM. Other languages like Clojure, as I said, Json and everything, they're trying to do the same thing, Groovy for that matter.
So JVM is platform dependent, right? But the bytecode is platform independent.
Right.
But JVM by itself is again platform.
Yes, yes, but it is available in various flavors. Yes. So underneath the covers, how JVM is written, right? As I mentioned, right, JVM eventually is written in C, okay, and it is written in a platform-specific manner, okay. But what it does is all the JVMs follow what is called JLS, right, which is inherently missing in other like C++ languages, right? JLS is Java language specifications, okay. All JVMs before they actually, like IBM has its own implement of JDK. Azure Systems has its own implement of JDK. They all follow the same JLS, but they are specialized in different ways. Like Azure System gives you a garbage, like a very less garbage collection as compared to the Oracle JDK, right? There is an open JDK. But all of this, what they have in common is they follow JLS, Java language specification. That's what gives you a consistent threading model across various platforms. That's what gives you a consistent view of bytecode manipulation across different platforms. Okay. All right. So the first thing is, I will say Scala is more scalable than Java. And that's where Scala gets its name from, actually. Scala stands for scalable language, right? And why do I say that? I mean, I'll give you a practical example. When Java was actually written by James Gosling in 1992, his actual creator, um, at that time, they made some fundamental, like it was actually inspired by C++. That's why you will see a lot of syntax is copied over from C++. Actually, they call it Java as C++ minus minus, means it's a C++ code mostly, but minus the obscurities which were in C++. There were some design decisions which were made, which over the time turned out to be wrong. Okay. For example, they built into the language itself, like the notion of plus, minus. These are things which are built into the language itself. They are not an external library. Okay. Unlike Scala core is a is very limited in its scope. Like its basic programming constructs are very small, and what Scala lets you do is it gives you libraries on top of it. Okay, that's how you enrich the library, and that's what the secret of its success is. I'll give you a small example of it, right? Like in Scala, for example, you can define plus as a method, right? Scala will let you allow method names which can be any kind of symbol, while Java will never let you allow it, because Java, the plus meaning is ingrained into the language itself, right? So I'll just give you a very simple demo, and we will write a very simple class in Scala, and we will try to do it, and we'll try to run it. Okay. So I'll use an atom for this, and maybe we can new file. Okay. I'm just going to close this. Close this. Okay. So we'll run this in REPL, but I'll code it over here because in REPL it's very hard to code a class. Okay. So I'm going to write a very simple class. I'm going to actually write a very simple class called complex. I don't have to write class complex, and complex takes two variables, and I'll explain. I'll just real quickly, step by step, what I'm doing. Wall, let's say, real part of an imaginary number, so it's of type int, and wall imaginary part, and it's of type int. Okay. And we'll quickly go through it once I finish coding this. So let's define a very simple method called plus, which takes another variable, which is, we call it, let's say, operand. It's of type complex. It returns a complex equals to, let's see, new complex, and we will say real part is real plus operand dot real and imaginary plus operand plus imaginary. Okay.
There's a typo.
I'm sorry?
Complex.
Oh yeah. Complex. Override that to string. Okay. I'll return real plus if x is less than real house plus. So this will be another. I'll explain real quickly. Let me just code this real quick and then we'll go through it. Plus imaginary plus. Okay. So let's go through it real quickly. So we are writing a very simple class called complex. It's going to represent a complex number, right? Again, I don't have to write the public keyword over here, just like in Java, because it's already there. For me, it's defaulted, the scope in Scala. Then I write the keyword class, followed by the name of the class called complex. And then you will see that I said wall. Wall is basically a final reference. Okay. The moment you will put wall over here, right? First of all, this whole thing is the constructor of this class. Okay. So in Java, right, you have to define a new method. Like you will basically write a new sort of method which has no return type and the name with the same name of the class, and you call that as constructor, right? And it will take the parameter types. In this case, you don't have to. In Scala, the way you define constructor is you define it in the first line over here. This whole thing is a constructor for this class. Okay, this constructor of this class takes a val real, which is of type int. Okay, val means a final reference, right? It's just like a final keyword in Java, followed by the name of this variable type, followed by the colon, which now I'm going to give it the type, which is int in this case, and then val again, imaginary, again of type int. When I put the val keyword, getters are automatically generated for me in Scala. Okay, if I put a var keyword, getters and setters are already generated for me in Scala. If I don't put anything, they become private. Okay, so just keep that thing in mind, that you need either if you want to be accessible outside, at least read access, you have to put either a val, or if you want it to be modified outside, which is not a good idea because it's not preferred, you should use var. Okay, then I'm defining another method. As I said, the way you define a method in Scala is to put a def keyword followed by a plus sign. Like that's a method name. I don't have to call this, like we have restrictions in Java that we can't use a plus sign for a method name. In Scala, there is no such restriction. Okay, because Scala, as I said, doesn't have plus sign built into the core of the language itself. It's just a library, right? And you define it. Okay, so followed by I'll say that I will take an operand, which is of type complex, right? And I will return a complex type. It's captured over here. Okay. Then the next thing you will notice is I'm not even using the return keyword in Scala, like in Java. In Scala, the last line in the method is your return. Okay. So over here, I don't have to write return. You can do it and it will do fine. I mean, it's not a problem. Scala will still compile it, but you don't have to. And it's a best practice not to do it. Okay, so basically I'm over here saying is I'm going to create a new complex, right? I'm going to add this real part to the operand real part, and I'm going to add the imaginary part of this complex class to the whatever is passed in imaginary part, right? So this is basically a method over here, and it's defining a plus method, right? Then followed by that, if you notice, I used an override keyword, and I overrode the main method, the toString method. Like just like in Java, everything extends from object class, and object has toString method in it, which gives the toString representation of the class you're writing. You get all the methods in the same. I mean, Scala objects, Scala classes actually extend from object, Java object. So all the equals, hash code, toString can be overridden in your classes. So over here, I'm actually overriding. And by the way, whenever you are in 1.5, they introduced the concept of annotations, and they introduced add override annotation in Java. And they said, Well, you can put this override annotation, and if you are trying to override a method and you have the override annotation, then the Scala compiler will actually check for you that you are actually overriding a method, right? And if you are not, if your signature is wrong and you meant to override it, but you didn't, the Scala compiler will give you an error at compile time itself. I mean, that's why override is introduced. But Scala actually mandates it, that you put it. And the reason it puts it, because you will ask, it's best practice. If you are saying that you are actually overriding a method, right, you should actually say that you are overriding a method. So Scala adopts some of the best practices which are optional in Java and makes them mandatory in Scala. Okay, and for good reason. That if you're saying you're overriding, you should override method, right? So over here it says def toString. Now I intentionally left out the return type over here. I can put return type. First of all, one thing you notice that over here I don't have no operands. Means I don't, the toString method does not take any input, right? So it's optional. I can do it this way, in which I'm specifying that there is no arguments to this method type. I can call this method without any argument type, or I can omit it. Okay. The other thing is I can mention the type, but I can also omit it.